All right, so we're going to do some integration with u substitution. So we're kind of sort of undoing the chain rule. And what's going to happen is just like we had to, well, hang on, u substitution. All right, so go back to differentiation for a second. If I was going to differentiate 8x plus 1 to the 7th power. All right, so what I would do is I would drop my 7 out front, times what's sitting there, drop my exponent by 1, and then the new part was times the derivative of the inside. Well, the derivative of the inside was 8. Okay, so that ended up cleaning up to 56, 8x plus 1 to the 6. So the question is, where did the 8 come from? The 8 came from the fact that I needed the derivative of the inside. So when we do this, what's going to make you mad is that you're going to generate some numbers and then they're going to randomly disappear. But they're not disappearing. We're going to change stuff into terms of u's and du's. So when I ask you for your u, I want to know what is on the inside. Okay, it can be the inside of a radical, it can be the inside of parentheses, it can be the inside of a denominator, the inside of something. Okay, what's on the inside? Once you tell me what your u is, I need to know what your du is. In other words, what's the derivative of that inside part? Okay, so find out, make sure you have the derivative. And if I need the derivative, then I can always make it as long as it does not involve variables. In other words, if I need an 8, I make an 8. Okay, so that is what we are doing in this. So the first couple questions, actually the first whole question, is going to be, what is your u? So my function on this one is going to be an indefinite integral. It's an x to the 6th, and then I have a square root of an x to the 7th plus 3 dx. So I want to know, what is your u? Your u is going to be what's on the inside. So of all of this stuff, I have a radical. What's on the inside of the radical? The inside of the radical is an x to the 7th. Okay, so your u is just x to the 7th. And now what I need to do is find that thing's derivative. So as soon as I've established, hang on, I just totally lied, plus 3, okay, x to the 7th plus 3. All right, now I just need to know, ignore everything else up there, what is that thing's derivative? His derivative is 7x to the 6th dx, okay? So you're thinking, what? What just happened? But hang on, let's do this one and you're going to see a little bit better. So for number 2, what I have is 7, hang on, all right. I have a 7 plus 7x to the 8th, and then I have times a 7 dx. So what is your u? First of all, notice that the inside does not have a derivative of 1, okay? So what is your u? What's on the inside? So my u is going to be the inside of these parentheses, which is a 7x plus 7. And I just changed the order than what it's written because I like things in descending order. All right, as soon as you do that, tell me what your du is. So notice I have a u. Take his derivative, and it's 1 du. Okay, what is this thing's derivative? This thing's derivative is 7, and then I took the derivative in terms of x, so it's 7 dx. Now here's the fun part. Hang on, I forgot to take out a colored pen. All right. So what I have is this part just turned into a u. So now what I have is u to the 8th, and then this part changed into my du. So that becomes du. Now if we had started with just this, and if I asked you to integrate that, you would say, oh, well, that's just u to the 9th over 9. And that's it, you're done. So this becomes u to the 9th over 9 plus c. because you have u and you have its derivative. Okay? So now the only issue is I started in x world, so I better end in x world. So take it out of u's and rewrite this. What is my u? My u is 7x plus 7 raised to the 9th power over 9 plus c. Okay, now how do you take your derivative? How do you check? So remember, the derivative of any constant is 0. I could drop my 9 out front, which would cancel with this 9. And I would have 7x plus 7 to the 8th times the derivative of the inside, which is 7dx. So what you're doing is you're balancing everything so that if you were to differentiate this back to the original, I'm sorry, if you if you were to differentiate this, you would get the original integrand back. Okay, so it just seems, it's kind of like, where did the 7 go? Remember that this is a package deal. That is your du. So just like what we've been doing before, it'll just disappear. Where did it come from? It came because you took a derivative. Where does it go? It goes away because you're integrating. All right, so we're going to rip through a couple of these things. I'm going to try and get this thing done in one video. Hang on, I can't do this. X squared minus 8. So I have the integral of x squared minus 8 times 2x, hang on, to the 4th, times 2x dx. So the first question is, what's your u? My u is whatever's on the inside. So x squared minus 8. Take the derivative of both sides. So the derivative of u is 1 du. What is this derivative? It is 2x dx. So what do I have? This is my u. So it's going to be rewritten as u to the 4th. This is my du. So now rewriting, I've got u to the 4th du, which just makes all this messy stuff a whole lot easier to look at. Do I know how to integrate that? I sure enough do. So he's a u to the 5th over 5 plus c. Okay, and then I started in x world, so I better end in x world. So this becomes x squared minus 8 to the 5th over 5 plus c. Okay, so let's find something more exciting. Well, let's do this one. It's not as exciting. Whatever. All right, so I have the integral of the cubed root of 3 minus 2x squared times negative 4x dx. What is your u? Your u is whatever's on the inside. Now, here's the question. You have this inside and you have this inside. So if you've got to make a decision, what you're looking for is who has the derivative. Okay? Well, this thing's derivative is a negative 4x. So that's your u. This is your du. Okay, so I got a 3 minus 2x squared. Take the derivative of both sides, so I get a negative 4x dx. So when I rewrite this, that's my u, that's my du. So now I'm going to rewrite this as u to the 1/3 power, because this quantity is raised to the 1st, but I'm taking a cubed root, and then the rest of it's a du. So when I integrate, that becomes 3/4 u to the 4/3 plus c. But you started in x world, so you better end in x world. So I've got 3/4 u to the 4/3 plus c. All right, so let's do another one. We have, okay, so let's do one where we've got to balance. Of course, they can't stay this easy. So what I have is the integral of x squared times x to the 3rd plus 5 raised to the 6th power dx. So again, I know I'm going to have to undo the chain rule because the derivative of the inside is not 1. So what's your u? Your u is the stuff on the inside. So x to the 3rd plus 5. Your du is 3x squared dx. Well, now I have a trauma. I got the x squared, I got the dx. I'm missing a 3. Okay, well, I can make a 3. Look, there ye is. Okay, the issue is I cannot randomly multiply things by 3. If I could randomly multiply things and it be okay, then I would multiply my bank account by $5 million. So that's not going to happen. I've got to balance this. What I can do is multiply by 1. Okay, so I need this 3x squared, but I'm going to balance by multiplying by 1/3 or dividing by 3. So what is 1/3 of 3? It's 1. Okay, so all I've done is multiply by a 1, but I've forced an instance. This 1/3 is coming along for the ride. This is your du right here, and this is your u to the 6th. So I've got u to the 6th, du. Your 3 is still in there. It's just hiding inside the du. Okay? So when I integrate, I'm going to get 1/3 u to the 7th over 7, which becomes 1/21st u to the 7th plus c. Well, what's your u? It's x to the 3rd plus 5. So what happens if you take your derivative? You would drop your 7 out front, so 7 over 21 would reduce to 1/3. And then x to the 3rd plus 5 to the 6th, x to the 3rd plus 5 to the 6th, times the derivative of the inside, which is 3x squared dx. So this was a 1/3. That's a 3x squared dx, and so your 1/3 and your 3 would cancel, and you end up with the original stuff in pencil. So you're balancing so that you have enough constants to go along to generate what was there to begin with. Okay, let's do a couple more. I'm trying to get this into 2 videos and not 3. So we have 9x. So I've got the integral of 9x over 5 minus x squared to the 3rd dx. Okay, so this is something that you learn along the way. I'm going to look and see what the inside of this thing is. The derivative of the inside is a negative 2x. I have an x, but this 9 is in my way. Okay, I don't like the 9, so I'm going to pull the 9 out because he's cluttering my life. And now I've got an x, 5 minus x squared to the negative 3rd dx. So all I've done is bring my denominator up top with a negative exponent. What's your u? My u is a 5 minus x squared. Trash. 5 minus x squared. My du is a negative 2x dx. So I've got the dx, I've got the x. What am I missing? I'm missing a negative 2, so balance by dividing by negative 2. So my new lead is a negative 9/2 times the integral of u to the negative 3 du. So again, my negative 2x dx is just hiding inside of that du. Okay, my 5x or 5 minus x squared is hiding inside of that u. It's all still there. I'm just making it a whole lot easier to manhandle. So when I integrate, I get a negative 9/2 u to the negative 2 over negative 2 plus c. These negatives cancel, and those denominators combine. So I actually have 9/4 u to the negative 2 plus c. But you started in x world, so you better end in x world. So I get a 5 minus x squared. And again, check your work by taking a derivative. And if you get the same thing back, then you did it right. All right, hang on. Well, never mind. I got to start a new video anyway. I ran out of lead in my pencil.